Hi students, this next video is designated for explaining ray optics. In other words, the ray model of light. So this model of light essentially says if light shines, then what we're going to do is trace where light shines and the path that it goes on. Now, it's important to note that the ray model of light operates kind of like lasers do. So it's not, you don't get light that just sort of decides to go in all different places. That's not how light operates. It moves in straight lines until it encounters an object. So we have an apple here, and our apple is red, and so what happens is that when we have light coming in, let's say from the sun, so when this light comes in from the sun, it is going to encounter the apple and it's going to bounce off. Now, it's going to selectively bounce off based off of what color it is. So what we see is red light bouncing off rather than yellow light, which is why the apple looks red to us, right? So the red part of this light is scattered, and it's scattered in every direction, creating new, weaker rays of light. And when one of these red lights encounters an eye, then the eye interprets the light, so it absorbs that light, and what you see is the red light that bounced off of the apple. So this is the process of seeing, and this is the process of light going about its ray model of travel. So yeah, there's a lot of really specific stuff that happens with waves and all that stuff that we talked about in the last video, but this is a much easier and simpler way to model what happens to those waves when we're looking at everyday objects. And so this is a practical way of looking at light in order to understand its effect on us. Now you might be saying, hold on, you said this reflects, and yeah, sure, an apple seems a little bit reflective, but what about something that doesn't really seem reflective, like maybe an apple that's not waxed, or maybe a piece of fur? Yes, the light still reflects off of that. So the question is, why are some things reflective and other things we don't call them reflective, even if they're reflecting light? To better describe that effect, what we need to do is zoom in on a smooth surface and a rough surface, and we have a source of light that's shining on our surfaces, and we can look at what happens on both of those surfaces. Now, what is always going to happen when light hits a surface is called the law of reflection. Now you've already got a pretty decent idea about what the law of reflection states. If you've ever bounced a ball and haven't really spun it or anything like that while you were bouncing it, that basically tells you intuitively what the law of reflection is, which is that if it comes in at some angle here, and we'll go ahead and put the vertical here, and we'll put some angle theta here. If it comes in at some angle theta, then when it hits a surface and reflects, it's going to leave at the same angle that it approached. So we call this the incident ray, and we call the next one the reflected ray. And we know that the incident angle and the reflected angle must be exactly the same according to the law of reflection. Now this is kind of what I was talking about by bouncing a ball. You know that it's going to basically do this, right? This is the law of reflection, and hopefully it makes a lot of sense to you. Now the thing is, that works perfectly fine on this smooth surface, as all the rays are going to leave at the same angle that they all came in on. But on a rough surface, this law works out a little bit more chaotically. And this is what we observe when we see light reflecting off of something like a carpet or a piece of paper, something that's a little bit rough. Whereas on the smooth surface, if you see something very, very smooth, like polished metal or a mirror, then you're going to see a different kind of reflection. We have names for these two types of reflection. They are specular reflection and diffuse reflection. Okay, so this hopefully explains the idea behind reflection. Now, once that we understand that, we can actually look at mirrors a little bit more closely. Now, a mirror that I have shown here has a very smooth surface on the left and a not smooth surface on the right, but we're not really concerned about the right side because the left side of the mirror is the side that we're looking into. And what I mean by that is that there's a person over here. So there's a person looking into the mirror from the left side pointed toward the right. Now what we're interested in is something called image formation. So we're going to have let's say a little symbol on this person's shirt. So when this person looks at the mirror, when they see this image, then we could use the law of reflection and the idea of ray optics, or the ray model of light, to figure out where that person sees that object. Now let's check some rays. We know that those rays are going to bounce off of the mirror and go into the person's eyes, and that's the only way that that person is going to be able to see it. If we have rays, and we do have rays that do not bounce off the person's, or go into the person's eyes, they bounce off the mirror and they go off in some other direction. But we're not interested in those rays. We're only interested in the ones that we see. So the one of the ones that we see is going to bounce. Let's say that's about right there. So that ray is entering that person's eyes, right? And then we also see another ray from a different part of the triangle that is entering the person's eyes. I want to change the color of this other one because I don't want it to look exactly like our ray, right? I want it to look a little bit different than that. So let's actually make it a little pinker, something like that. Okay. So I'm going to take the other corner over here, or maybe I can take the bottom of the triangle here, and we also want to make sure that this one goes into the eyes, because there may be a ray right here that bounces off in the same way that the other one did, but the person is just eating that ray. That's not helpful. We're interested in a ray that's actually going to bounce off the mirror and go into the person's eyes. So we're actually going to be dealing with a ray that's at a little bit of a different angle, right? Like so. Okay, great. So those are two rays from the same object, different parts of the object, that are entering the person's eyes. And now what we can do is we can trace back the pink ray so that the person sees the object, but really what the person sees is only a representation of the object, an image, like so. Now that's about the right distance, because it might be so many centimeters to the mirror and so many centimeters to the triangle, but what the person sees is so many centimeters to the mirror and then the same number of centimeters to the triangle. And so what we're doing is seeing that the bottom of that triangle, this is where the person sees the bottom of that triangle. Now if we trace back the other one, we can see the same concept with the red ray of light as we saw with the pink ray of light, where it appears to have come from this direction. And what you see in the mirror is then a triangle that looks like the triangle on your shirt, and the mirror is fooling you into believing that it's a different location than it actually is. This is what we call an image location. And mirrors are all the time fooling us about these, and that's not such a bad thing. It's actually useful for us, right? We need it to fool us into believing that, because otherwise we wouldn't be able to see our own, let's say, eyebrows or whatever. So okay, so this is the idea of image formation. And there are many other types of image formation. We don't want to go too far into it, but I do want you to understand the basic idea of reflection, so that you can and understand the basic idea of ray optics, so that you can have a general sense of how light works and how we see it. Okay, let's do our video summary. The first thing that we learned about was about the process of reflection, and we learned that the law of reflection is what dictates how light bounces off of things. We stated that the law of reflection is that the incident angle that light comes in is the same as the reflected angle that the light leaves. Okay, we also learned that there was a difference between diffuse reflection and specular reflection. So remember that diffuse reflection is scattered light, and specular reflection is like mirrors, right? So I'm going to put mirror under here. Whoops. So I'm going to put a mirror. Okay. Now the other thing that we learned was about image formation. And image formation is the process of us being fooled, or even a camera, really, anything that sees, right, is going to see an object's location in a different place than the object actually exists, because what it's actually seeing is the image. And finally, all of this is tied together under the ray model of light. Okay, if there are any questions, throw them at me. I'm going to move on to the next section of light, where I'm going to describe something called index of refraction, so that we can observe what happens with light when it goes into materials.